This presentation is to assist emergency services personnel when dealing with electricity. This material is for general guidance only and should not be regarded as a substitute for professional advice. Such advice should always be taken before acting on any of the matters discussed. Electricity is essential for our economy and is so much part of modern living that we can often take it for granted. Electricity is a powerful and versatile source of energy, but it can be dangerous unless we use it safely. Every year, people are injured or killed through contact with electricity. In this presentation, we'll cover common mistakes, incidents, and rules to follow, so that you can always be sure of the correct way to respond while keeping yourself safe. After this presentation, you'll have a basic understanding of the electricity network, the hazards associated with electricity, and what precautions to take when dealing with electricity. You'll see examples of actual incidents involving members of the public, the services and construction industry, and incidents involving the emergency services. ESB Networks builds, operates and maintains the system through which electricity flows across Ireland. We bring power to homes, businesses and communities. We carry out all the functions relating to the electricity distribution system. This includes planning, construction, maintenance and operation of the distribution networks, including the electricity meters. This means overhead wires, underground cables, substations, poles and towers that distribute electricity to customers right throughout the Republic of Ireland, regardless of which electricity supplier the customer purchases their electricity from. The ESB network system is made up of many different types of equipment: poles, masts, overhead wires, underground cables, mini pillars, and substations, both pole-mounted and ground-mounted. The ESB network system is continuously changing and growing in size as Ireland's electricity needs increase. It is ESB Network's policy to promote public safety, but serious injuries and/or deaths still occur every year due to inadvertent contact or near contact with electricity networks. There are many reasons for this, but the most common is simply a basic lack of awareness of the dangers of electricity. There is also complacency by people working in the vicinity of overhead wires, failure of parties to act responsibly, and failure to implement safe systems of work, which includes compliance with relevant codes of practice. You'll find information at esbnetworks.ie. Before we get into the details, let's first cover some basic facts about electricity. Contact with electricity can cause death or serious injury. Persons who place themselves between any two energized conductors or any energized conductor and the ground will become part of an electric circuit. Electricity will always seek the easiest path to the ground. This is true whether the electricity comes from a simple household circuit, a high voltage power transmission wire, or from lightning. Electricity systems in Ireland carry voltages up to 400,000 volts, and contact with even 50 volts can be lethal. Never assume electrical equipment is safe to approach, even if wires have fallen or are broken. Overhead electricity wires are not insulated. Remember that the electricity can be switched back on at any time without warning. Touching electricity wires, cables, or objects, persons, or vehicles in contact with wires or cables can be fatal. Electricity can jump gaps. Trees, strings, ropes, and crash barriers can conduct it. Never put yourself in danger. Overhead wires are involved in a number of injuries and/or deaths every year. When it comes to dealing safely with them, there are a number of things to bear in mind. Look out and look up for overhead wires before you start. This should be part of your risk assessment. electricity can travel through the ground, stay back a minimum of 5 meters. Treat all overhead wires and underground cables as live. Don't assume they're dead or switched off. Even if they're broken and have fallen onto the ground or onto another object such as a vehicle. Despite what you may believe about rubber or PVC, wearing rubber boots will not protect you. While rubber and PVC do insulate, they cannot be relied on to prevent electric shock. It cannot be stated clearly enough that coming into contact or near contact with fallen wires can be fatal. Always carry long objects such as ladders horizontally and never above waist height. A hazard zone is an area around overhead electricity wires which must be isolated from the worksite by the use of physical barriers. This is done to minimize the risk of contact or near contact with the overhead wire by plant, equipment, scaffolding, or other materials as construction work is carried out. The dimensions of the hazard zone are related to the voltage of the overhead wire and are different for each voltage level. An exclusion zone is defined as a region around a live overhead electricity conductor which must never be breached in order to avoid electrical arcing or flashover. The concept of the exclusion zone is illustrated here. The dimension R of the exclusion zone is related to the operating voltage of the overhead electricity wire. The exclusion zones when operating plant, such as cranes, concrete placing booms, excavating equipment, mobile elevating work platforms, MUPs, and other plant and materials are specified here. This information is from our Code of Practice and can be accessed at esbnetworks.ie. When talking about electricity, there are a few key terms you'll need to know. Voltage. Voltage can be likened to water pressure. It's the force that causes the flow of electricity. Current. Current can be likened to the rate of flow of water in a pipe, measuring just how much is coming through at once. Resistance. Resistance is like the friction to the flow of water. Different materials have different resistances to the flow of electricity. High resistance materials that limit the flow of electricity are called insulators, while the low resistance materials that do not limit the flow are called conductors. In an electrical system, the force or pressure is measured in volts, the current or flow is measured in amps, and the resistance is measured in ohms. Now that we have a basic definition, we can explain two different effects that may one day save your life and the lives of others. Many of the deaths and/or injuries that occur every year in Ireland are associated with trucks or other large vehicles making contact with overhead wires. Making contact or near contact with the tall frame of a vehicle like this will result in current flowing through your body to the ground. Depending on the voltage, an arc can jump across from the electricity wires to the top of the truck. As we've already heard, overhead electricity wires in Ireland can carry up to 400,000 volts, and remember, just 50 volts can kill. Another type of voltage to be aware of is step voltage. When electricity makes contact with the ground, there is an effect much like the rippling effect you get when you drop a pebble into calm water. The electricity will fan out from the point at which the live wire or conductor touches it, getting smaller as it rings out. This means the electrical energy is at a maximum voltage at the point of contact with the ground, but as you move away from the contact point, the voltage level drops progressively. In this illustration, voltage may be present between both legs. This is known as step voltage or ground gradient, and being aware of how it operates may very well save your life. The effect of electricity on the body depends on the amount of current and the length of time the body is exposed to it. The higher the current, the less time a human can survive the exposure. The path of electricity through the body is also critical. For example, current passing through the heart is more life-threatening than current passing through the fingers. It is the current that kills or causes injury, though the voltage, which pushes the current through the body, is also important. Possible outcomes of contact with electricity include death, electric shock, internal burns, external burns, blast injuries, and contact with even 50 volts can be lethal. If your vehicle or machine comes in contact with an overhead wire, stay calm, disengage gently, back away if possible, call our emergency number, and if you can, stay in the cab. If risk increases, do not step down, but jump clear and keep all other people clear of the vehicle. Be aware of touch and step voltage as previously explained. Whatever you do, do not make contact with ground and equipment at the same time. This will make you part of the circuit and could mean serious injury or death. Here are just some of the activities that lead to accidents. Road traffic collisions with electricity poles and other equipment. Vehicles tipping or loading near overhead wires. Operating cranes, construction or agricultural machinery near overhead wires. Contact with overhead wires while erecting scaffolding, fishing, moving or erecting long objects near wires. Contact due to damage to underground cables while excavating. Incidents such as illegal activity, antisocial or irresponsible behavior at towers, substations or poles. Emergency services personnel not being aware of the hazard associated with electricity when dealing with incidents. Two people building this scaffold came into contact with a 10,000 volt overhead wire. Both received an electric shock resulting in minor burn injuries. A person cutting trees came in contact with a 20,000 volt overhead wire, resulting in a fatality. While erecting temporary lighting for car parking, two people came in contact with a 10,000 volt overhead wire, resulting in 2 fatalities. In this car accident, with an ESB mini pillar under the vehicle, there is a serious risk that the vehicle could be live and kill on contact. These are archive photos of incidents at construction sites. The following are real examples of incidents where members of the emergency services put themselves or others in danger by not knowing how to properly deal with an electrical emergency. A member of the fire service entered a 38,000 volt substation, cut and removed a protective screen, and entered a live 38,000 volt cubicle to remove the victim. Remember, just 50 volts can be lethal. Gardaí arrived at the scene of a truck that was in contact with a live 10,000 volt overhead wire. They parked their vehicle very close to the live truck which was on fire, then walked around the area, breaching the exclusion zone. A member of the fire service climbed a 38,000 volt mast using a ladder to remove a victim with the wire still live. Here, a member of the fire service hosed down trees that were on fire due to a fallen 10,000 volt overhead wire that was still live. In this incident, members of the fire service opened the protective screen around a 10,000 volt transformer to remove a victim. A member of the public was injured when hit by falling 20,000 volt wires. The fire brigade were attending to the victim beside the fallen wires and were not aware of the potential danger. The fallen wires may still have been live at 20,000 volts. To download the emergency services guide, visit esbnetworks.ie. Don't disturb or touch any fallen wire or conductor. Don't disturb or touch any underground cable. Don't enter any substation without first checking with ESB networks. Don't remove any guards or screens around ESB networks equipment. Do assume all equipment is live unless otherwise confirmed with ESB networks. Do keep clear of any live equipment. Do assess the risk before proceeding. Do keep members of the public clear. Do contact ESB networks at the earliest opportunity on 1-800-372-999 or 021-454-2090. Do consider the risk of electrocution when dealing with incidents involving electrical equipment. Do ensure electricity supply is switched off before dealing with an emergency situation. When ESB networks equipment is involved or in the proximity of an incident, contact ESB networks immediately through our National Contact Centre on 1-800-372-999 or 021-454-2090. You must provide the following information: address, GPS or XY coordinates, equipment identification number or name. The identification number of the equipment is only important if it is safe to access this number. Never climb or touch anything that may be in contact with electricity to find this information. Remember, coming too close to our equipment is always dangerous. Always contact ESB networks immediately where there is a risk from electricity. ESB networks emergency staff are available 24/7 to respond to incidents involving our networks. And now that you've learned how to correctly respond to the most common events and incidents, it's in your hands. Stay safe, stay clear of electricity cables, wires, and equipment.